On problem number 23, notice it says the graph of 3x minus y is equal to 1 is shown on a grid. Which points are in the solution set of 3x minus y is greater than or equal to 1? Select 3 correct answers. So we're looking for 3 different answers. They're going to be correct. And I hope you remember that when we were doing inequalities, I had a favorite point that I always checked. And so notice we have a left side of the graph, right? And then we have a right side of the graph. Now, they do have this graph property as an inequality, right? Because this line is solid. So we see that this line, it says that it's a graph, right? It's an equation. But remember, when we have this greater than or equal to sign, this will normally be a solid line. So imagine it just like those inequalities we graphed in class. And we're going to use my favorite point, 1, 1, to see if everything on the right side should be graphed or if everything on the left side should be graphed. And we're going to use our true-false feature inside of the calculator. And that'll let us know which dots we need to touch. So let's go ahead and I'm going to write this down real quick. My inequality is going to be 3x minus y is greater than or equal to 1. So we're going to be substituting some values. Now I'm going to go ahead and I'm looking at the right side of my graph and I go, well, look, 1, 1, notice is clearly far away from the line. So it's a good point to go ahead and check. And so Mr. H is going to write this down. Let's see, I'm going to put my 1, that is my x value, and remember that the second one is my y value. So I have my ordered pair that I'm going to test, and what I'm going to be doing is I'm going to replace the x with this value of 1 here in parentheses, and I'm going to replace the y with a value of 1 in parentheses. And everything else I'm just going to bring down. In other words, we're bringing down to 3. So that's 3 times my x value, which is 1, because that's a test point I'm using. Bring down my minus sign and my inequality symbol. And bring down this value of 1. So now that we have this written, we're just going to put this in the calculator. And what we want to remember is, I'm just going to draw a picture for you real quick, is when we get our answer, because this is a sketch of how our line looks right now. If it says true, then that means the point 1, 1 that's roughly over here will be the shaded area. So if it says true, we'll shade this area. If it says false, we would shade the other side of the graph. And so that would mean that all the points on this side are correct. So let's go ahead and put that in the calculator and see what we get using our 0.11. Alright, I'm going to hit OK. I am just going to type this straight into here. So let me go ahead and put in my 3, my parenthesis for my x value, which is 1, close parenthesis, minus my y value, which is also 1, close parenthesis, and then is greater than or equal to. So I'm going to hit Control and then equal, and it pulls up my inequality symbols. So I'm going to go to greater than or equal to, and then I'm going to put a 1 and hit enter, and notice it says it is true. So what that tells me is that everything on this side of my graph must be shaded. So that means 1, 1 is part of the solution. So I'm going to go over here, I'm going to click this point is the solution, this point is the solution. And the last one that we have, really that may throw some confusion, is notice they put this point on the line. And so some of you may be going, well, you know what, Mr. H, do I pick the point on the line? Because it says I got to pick 3. Well, you can rule out these two, right? Because these are on the opposite side, so it cannot be either of these. And it's telling you to pick 3. So yes, this has to be one of the answer choices. And let me tell you why this is a valid choice. Now, I've told you in class, never use a point on the line to check to see what side to shade. So you may not want to pick anything on the line. But the reason in this case it is okay for you to pick a point on the line is because of this symbol here. Remember that this symbol here, this greater than or equal to, means that it can touch the line. Because it can be any point in this area or any point on this line. Now, if this would have just been a greater than symbol, it could come really close to the line, but it'd never touch it. And in that case, when we graph them, typically when we have one that has a symbol like that, just to refresh your memory, we would have a graph, if it were to be graphed properly as an inequality, that would have a dashed line. And remember I told you with the dashed line, it just means we could come as close as we want to it, but we can never actually touch it. So those 3 points are the correct points. They're all true. And if we were to check them in a calculator, every one of them would say true. I'm just going to go ahead and further give you an example on that. This location of the point is 1 for the x value and 2 for the y value. So if I were to go back into my calculator and simply check it real quick, I can go ahead and change my y value to a 2, hit enter, and notice it's still going to say true. Go ahead and pause this video and then move to number 24 and see if you could do that on your own and get it correctly before watching it any further. In this sequence, it says a sequence can be generated by using the equation shown, where a sub 1 is 5 and n is a whole number greater than 1. And then it gives us an equation, a sub n is equal to negative 3 plus a sub n minus 1. And then it says, what are the first 4 terms of this sequence? Okay, well, what I want you to remember is, when we're looking at a problem like this, for instance, I have a sub n is equal to negative 3 plus a sub n minus 1. Now, we could use this formula here, but remember whenever we're working on these, when you see a formula like this right here, remember that this right here is either going to be your common ratio or common difference. So in this case, this is actually going to be a common difference. And it tells us what our a sub 1 is. So they've already told us that a sub 1 is going to be equal to 5. And I am going to show you how to use this formula, just to refresh your memory. But since they're giving me a sub 1, and I know that it's 5, and I know that this is the common difference, I could go ahead and list out the rest of them by just doing some simple subtraction. So I could find a sub 2, a sub 3, a sub 4. And the reason I'm going to stop there, because if you notice, in all the answer choices, they only have 1, 2, 3, 4. They only have 4 answer choices in every single one. And what I can do here is, if I know that a sub 1 is 5, and I know that my common difference is minus 3, what I can go ahead and do is subtract 3, and that gives me my a sub 2, which is 2. And then if I want to find my next one, I can simply go ahead and do the math on it. I'm going to do it right underneath. I can take this 2 and once again subtract 3, and that'll give me my a sub 3. So I'm going to go ahead and go to calculate, and I'm going to go 2 minus 3, and that's going to give me negative 1. So this becomes negative 1, and we're going to take that up to a sub 3. And then if I wanted to find the next one, I would simply take that negative 1 and subtract 3, once again, my common difference. So I'll get my calculator here, and let's go ahead and do negative 1 minus 3 more, and it gives me negative 4. And I'm going to write it up there. So now I have actually found the first 4 terms. So my terms are, they gave me a sub 1, which is 5, a sub 2 is 2, a sub 3 is negative 1, and a sub 4 is negative 4. This is by doing it by hand, right? Without the formula. We've practiced it both ways in class. We used the recursive formula, we used the explicit formula, and we also did this. So let's go ahead and take a look and start rolling some things out. So first of all, this has negative 3, then it says 2, 7, and 12. It is definitely not that one. And then we have 5, 2, 1, negative 1, and negative 4. And so it is that one. Notice these other two, they don't match. This one did start with a 5. It had an a sub 1 as 5. But notice that the next one, right, it went up to 8. It was increasing. And we don't have an increase going on here. Now, for those who want to see, if you're good with this and you remember it, you can go ahead and stop this video and go on. But if you want to see another way we could use that formula, just continue to watch. And this is what else we could have done. So notice they do give us this formula. And if I wanted to find, let's say I wanted to find a sub 2. So I want to find a sub 2. So I'm going to replace this in with a 2. And it's going to be equal to negative 3 plus a sub, and remember we replaced the in with a 2. So 2 minus 1. Now if I continue to do the math here, what I'd really end up with is negative 3 plus, and 2 minus 1 is just going to give me 1, right? So it'd be a sub 1. Now we know what a sub 1 is. We know what a sub 1 is. They gave it to us. They said a sub 1 is 5. So I could simply replace this with a 5, and I would end up having a sub, or this is equal to negative 3 plus my a sub 1, which is 5, right? And notice that's what we did basically over here. We wanted to find a sub 2. So this formula really works very closely to exactly what I showed you that we could just do really with simple addition and subtraction by hand. And notice I have minus 3, right, plus 5, and it gives me a positive 2. So I would say a sub 2 is equal to positive 2. Same thing we did up here. We just didn't use this formula, right? We didn't substitute it in. If we wanted to find the next one, we would just do a sub 3 is equal to negative 3 plus a sub 3 minus 1. And we would repeat the process, right? At this point, we would just say, okay, we have negative 3 plus, and we found, in this case, 3 minus 1 is going to give me 2. So that's a sub 2. And we had already found a sub 2 right here. So that would tell us to just go ahead and substitute our value for a sub 2 that we have found, which was 2. And we would do the math. And once again, we would have the same answer that we already got up here because we already followed that process, and it would be negative 1. So a sub 3 is negative 1. So we could use the formula, right? But if we understand that this value that's in here is the common difference, we could just go ahead and subtract it each time and find it that way, because that's basically what they're doing here, just in a more complex manner down here. Go ahead and pause this video after you've answered your question and try the next problem and see if you can get it correctly. Question number 25 says a football player sprinted at a constant rate. The part of the linear function shown represents the distance the football player sprinted in yards, y, as a function of time in seconds, x. What is the range of the function for the situation? Now I am going to highlight this word range because that makes a difference in what we're looking for. And what I want you to remember when we talk about domain and range, I'm just going to draw you a picture real quick. This is my y-axis, and my range is my up and down value. Let's go ahead and up and down is range. Then we also have what we call domain. So let's say we had an x-axis right here. So I'm going to write x-axis. And domain is our left and right. How far we go left and right. So you just got to remember this. So in this case, right, they're asking for range. That's very important. And what they're really saying is we want to know how far, right, this graph travels up or down. So we're looking at those values. Now I'm going to go ahead and notice we're going to be talking about inequalities. Range, since it's associated with the y-axis, anything that doesn't have a y, we can just go ahead and cross it out. We don't even need to check it because range only deals with the y values up and down. So I'm going to see if there's anything we can cancel out, just looking for that. And notice on A it has a y, so that's good. But B has an x. Do you see that? There's an x right there. It says x is greater than or equal to 0 and less than or equal to 9. So it's not going to be x, that's domain. And it's not going to be D because that has an x. So now you've got a 50-50 chance of getting it right, even if you make a mistake. So we only have two answer choices. We have a y here and we have a y here. That's both range. And so now we just need to see which one makes the most sense. Now I'm going to go ahead And on this, because they did give me a graph, I feel like this is a good one to use that grid that they have where you can graph and draw. I am going to make it transparent, and I'm just going to put it over it because I want to put some points on here. I'm going to add a point. So let me go ahead and I'm going to add a point right here. And then I'm going to move it to get it lined up really well. So I have a point right here. Notice this is the lowest I have on my range. Remember, range is up and down. And what's the lowest that it goes? The lowest it goes is 0. So I'm going to write that down. The lowest it goes is 0, which is going to be less than or equal to y. Now, this doesn't really help me much because if you look at my answer choices, they both have a 0, right? So that didn't do anything for us. But now let's see what's the highest that my graph goes. And now I know some of you may be tempted to put a dot over here on the right, but remember, we're just trying to see how high it goes on this y-axis so that we can measure it. So I'm going to put a point right there. I'm going to change the sizing of this real quick. So notice this point right here lines up with 80 right here. So the highest it goes is 80. The lowest it went is 0. So that tells me, since I know the highest it went and what lines up with this point right here is an 80, I'm going to go ahead and write over here, this has got to be less than or equal to 80. So that is my range. My lowest value goes on the left, my highest value goes on the right. And I have a y in the middle because that is the axis that we are looking at to determine how far it goes up or down. And out of those answer choices, if I come down over here, notice that the only one that's possible to be correct is C. So A is wrong. A, looking at A, that's actually talking about the domain, right? From 0 to 9, that's left and right. Go ahead and pause this video now that you've got the correct answer, and try problem number 26 on your own before watching it any further. In problem number 26, notice it says which expression is a factor of negative 6x squared minus 19x plus 20. So we are going to have to find a factor. And I think this one is going to be a little bit more challenging than some. Some of them will actually give you both factors, and you can just FOIL it out and see if it matches the answer. In other words, we can work backwards. In this case, this one does not allow us to work backwards. So that makes it a little bit more challenging. So we are going to have to use our factoring method that I taught you in class, where we multiply a times c, and we also check to see if we need to pull out a greatest common factor to determine which one of these factor sets is correct. So let me show you, just to refresh your memory on what we would do. So first of all, I'm going to rewrite this. So I'm going to write this is negative 6x squared minus 19x plus 20. And I also want you to remember, I'm just going to write above it real quick, that when we have a quadratic like this, I want you to remember that the a value is that first number. That's my a value, right? And then we have the x squared, and then we have our b value. That's going to be this 19, and then after that we have an x, and then we have our c value. All right? Remember, c stands for constant. It's the number that does not have a variable. So what we're going to be doing is we're going to go through our steps here. First, I'm going to go ahead and look at the factors of 6 and see if any of that can divide into 19 or 20, because we always want to get out our greatest common factor. Remember, we call greatest common factor our GCF. So does this have a GCF? Well, I'm going to find out. I'm going to look at my factors for 6. So I'm going to create me a factor tree for A and see what they are. Now remember, when we're talking about factors, we have 1 and 6. We always start with 1. And then once we start with 1, we're just going to go to the number after 1 and check it and see if it works. So can 6 be divided by 2? And it can. It gives me 2 and 3. So I'm going to write 2 and 3. And after 2 comes the number 3, and it's already written. So that is all the factors. Now remember that when we're looking for GCF, we never want to use 1 as one of our factors. We just want to see, can the other numbers that are part of the, right, that are factors, can they go into our middle term? And if none of them can, there's no GCF and we can move on to the next step. So let's just check it. Our middle term is 19, right? Negative 19. So I'm going to put in negative 19. I'm going to divide that by 2. Notice I got a fraction, so it didn't work. So we can eliminate that possibility. Negative 19 divided by 3. It doesn't work. We eliminate that one. And negative 19 divided by 6. It doesn't work. We eliminate that one. So now we have proven that there is no GCF. There is no greatest common factor. So we can go ahead and move on to our next step. We verified there's no greatest common factor. The next thing that we want to do is we want to multiply A times C. So I'm just going to put right here, first multiply A times C. So I'm going to take the A value, negative 6, and I am going to multiply it to my C value of positive 20. Now those are big numbers, right? We're going to use our calculator to do that multiplication. So negative 6 times positive 20, and it gives me negative 120. Now what I like to do is just write the number directly underneath it. This is negative 120. And what that has done, temporarily, we have gotten rid of our A value. It's now been multiplied to 20. We have a new number here for our constant. I am then going to bring down my x squared, and I'm going to bring down my middle term, negative 19x. And we have a new quadratic, right? And this one's going to be much easier to factor because we have a leading term. Our leading term has a coefficient of 1. Now what I want to do at this point is I want to create my factor tree. So I'm going to put my second step here. I'm going to put second factors of C, right? We want to find our factors of C. What numbers can multiply to give me negative 100, or I should even say negative 120. We really just want to focus on the value. Don't even worry about the sign right now. So let's go ahead and write those out. Now we always know, right, we can start with 1 and 120. In this case, we might use the 1 sometimes. You know, if this middle term was 121, we would use these two numbers to get 121, or to get 119, right? If we were to take 120 and subtract 1. Now, the way I'm going to find my factors, right, is just like we did in class. I like to keep it as simple as possible. So I'm just going to start dividing by numbers after 1 until we find all the factors. So for instance, we had already said 1 times 20 is 120. The next number after 1 is 2. So I'm going to do 120 divided by 2 and see what it gives me. And it gives me a 60. So I'm going to go ahead and write those factors down. So we have 2 and 60. After 2 comes 3. So I'll just take that 120 and divide it by 3. And that gives me 40. So I have 3 and 40. After 3 comes 4. So I'll take 120 and divide it by 4. And it gives me 30. 4 and 30. And after 4 comes 5. So I'll do 120 divided by 5. And it's going to give me 5 and 24. So let me extend this a little bit. 5 and 24. After 5 comes 6, so I can do 120 divided by 6, and it gives me 6 and 20. And I can do 120 divided by 7, which comes next, and it doesn't work, right? Because we got a fraction. 120 divided by 8 gives me 8 and 15. I can then try 9. 120 divided by 9 doesn't work. 120 divided by 10, I have 10 and 12. So we're almost done. Notice we're getting to a point where we almost get to the same number. There's only one number left to try, and that number is going to be 11, right? Because 11 is in between 10 and 12. So 120 divided by 11, and notice it doesn't work. Now we have got all the factors for 120, and it is a lot of them, right? This is probably more than usual, but we got all of them. And now what we want to do is see if we put these numbers together left to right by either adding them or subtracting them. We're trying to get this center term. So really, I always look at it as adding because we're combining them, right? Sometimes they'll both be positive, sometimes they'll both be negative, a positive negative or negative positive, either way. So what we're trying to do is we're trying to get 19. So let's start checking them. Can I get a 19 out of a 10 and 12? Well, I can't, because 10 plus 12 is 22, and 12 minus 10 is going to be 2. So that doesn't work. Can I get a 19 out of an 8 and 15? Okay, well, 8 plus 15 is going to be 24, and 15 minus 8 is going to be 7. So that one won't work. And we could try 6 and 20. 6 plus 20 is 26. 20 minus 6 is 14. Well, that's closer, but it still won't work. 5 plus 24 is 29. 24 minus 5 gives me 19. That one works. Now, if you wanted to check the rest, right, because every once in a while you might have a situation where 2 could be a factor, but I can tell you just by looking at these, that's not going to be the case. 4 plus 30 will be 34. 30 minus 4 will be 26. That's far away from that, so that won't work. This would be 43 or 37. This would be 62 or 58, and this would be 121 or 119. So we only have one set of factors that can give us 19. So now that we know what they are, we just got to figure out which one's going to be positive and which one's going to be negative. And I know every once in a while I see students struggle with this. But remember what I told you is just guess and check. So let's go ahead and let's see what would happen if we made the 5 negative and the 24 positive. So if I went ahead and I made the 5 negative and I added that to 24, a positive 24, it would give me positive 19. But I need negative 19. So I'm going to try taking these two signs and just flipping them. So instead I'm going to do a positive 5 and I'm going to subtract 24. In other words, the 24 is now our negative number. And it does give me negative 19. So I need 24 to be negative and 5 to be positive. So 5 is going to be positive, 24 is going to be negative, and now we're ready to write our factors. So I'm going to go ahead and I'm going to write x plus 5 and then I'm going to write x minus 24. Now I've got my two factors. I am almost done, right? We did our first step, which was multiply, well, our first step, which is to rule out that there's no GCF. Once after that, our steps to solve, right? We're to go ahead and multiply a times c. We did that. We found our factors of c. We did that. So now we have these written as two binomials. So now that we got our factors, the last thing we need to do, right, is divide by a. So let's go ahead and do that. Now I'm going to put my division symbol. Notice a was negative 6. So I'm going to divide by negative 6. And then I'm going to divide the other factor by negative 6 as well. And we're going to let our calculator do all the work here. And remember that whenever we're dividing these out, if we have a change in what the fraction is, right? If this simplifies, then we need to go ahead and use that simplified version before moving the denominator in front of the x. So let's take a look real quick at what we have. I'm going to go ahead and put in 5 over negative 6. Now notice it does give me negative 5 over 6. So the only change that we have here is really just the sign. And so let me show you what I mean. I'm going to go ahead and rewrite this because I think it'll be clearer if I rewrite it. This has now changed from x plus positive 5 over negative 6 to x minus 5 over 6. Notice our calculator, right? It just has a negative sign on top, so it's x minus 5 over 6. This is going to make a difference because we have a sign change going on. The good news is now we're just going to take this denominator, because it's been simplified, and move it in front of the x. And so my final answer is simply going to be 6x minus 5. Then let's do the next one. We have negative 24 over negative 6. So we're going to go ahead, negative 24 over negative 6 and hit enter, and it becomes positive 4. So we had a sign change there as well. So this one is going to be x plus 4. And then that is our final answer. So now we have our two factors, and we're just going to see which one actually shows up on our test. So if I go back over to the test, and I go ahead, I'm going to do some strike-throughs. Notice the first one's 3x minus 5. That does not match either factor. B has 6x minus 5, which is one of them. So that's going to be the answer. C was x minus 5. D was 2x minus 5. So the rest of these didn't even come close to being the correct answer. So my answer is B. Go ahead and pause this video and now try number 27 on your own. On number 27, it says the function of f of x is equal to x squared is transformed to create the function of g of x is equal to f of x minus 2 plus 5. Complete the sentence about the transformation. So it wants to know what is occurring when we have this transformation. So let's go ahead and write down the things that we know for certain. We know for certain that f of x, the original, is simply equal to x squared. So this would be easy to graph, right? And I'm going to graph it right now. Let's take a look at what would that look like if we graphed it. So I'm going to go to my favorite graphing feature, right? The parabola down at the bottom, and it's going to open up. It already puts f of x for me, and I just need to type x squared. So this is our parent function, right? We have a parabola that goes through origin, has 1, 0. And so what we're going to do is we're going to modify it because it says it was transformed. But before we try to modify this, let's go ahead and look and see what they said actually happened. Now they said that it was transformed to g of x is equal to f. And so you know what? I should write this in pink because now they're going back to this one, right? So our f, that's our original, of x minus 2 plus 5. Now, I know for some of you, you're like, Mr. H, this looks kind of odd. Why did they put f of x minus 2? Well, they're just telling you what happened here. And so what I want you to think about is, and when this is f of x is equals to x squared, and so if they're changing it to f of x minus 2, well, they're changing this to f of x minus 2. And what that tells us is that anywhere there's an x, we're going to replace the x with x minus 2. So I'm going to rewrite this, and instead of having x squared, I'm going to replace that x with what's inside of the parentheses, which is just simply x minus 2. So parentheses x minus 2, close parenthesis, squared. So this change occurred. So what I want to do is if I want to write g of x, and I want to have it with the transformation in it, instead of me doing f of x minus 2, I'm actually going to write what the change would be on the right side of the equal sign. So it changed from x squared to this x minus 2. So parenthesis x minus 2 squared. And then I'm going to bring down the constant they added, right? Because there was two different changes they did. The first change was they changed x squared to x minus 2 squared in parentheses. The second change they did is they added 5 at the end of it. That's going to shift it. Now what I'll tell you is what we learned in class was anytime that we have a change to the x that occurs like this within the parentheses, it's always going to shift it left or right. And anytime we have a change where we're just adding or subtracting a constant, it's going to move it up or down. So we're going to have a horizontal shift and we're going to have a vertical shift. So this is two different transformations occurring to this particular function. Now let's graph it because I think it'll make more sense if we actually look at the picture. So I'm going to type this in. Now we already have our original one, right? It is on there. Well, I accidentally got out. Let me just put it in again. X squared. So there's our original. Now I'm going to type in the new one. And when I say type in the new one, I'm just going to type in what's on the right side of the equal sign. So I'm going to hit tab, T-A-B. That lets me open up another function. I can graph it on the same picture so we can see what changed. And I'm going to go ahead and put my parenthesis. I'm going to click on there, and I'll move this up. X minus 2, close parenthesis, squared. And then it was plus 5, right? We have a plus 5 there. So I'm going to go ahead and put plus 5. Hit enter. And there's the change. Now, we knew it was going to have a horizontal shift, and it did. If you look at it, it moved over to the right. And then we knew it was going to have a vertical shift, right? Either up or down. And if you notice, this actually went up, which makes sense because if we're looking at this, right? If we're looking at our equation, x minus 2, remember it always does the opposite. In other words, if it says minus 2, it goes to the right 2. If it says plus 2, it goes to the left 2. And then that positive 5 just took us and moved it up 5 units. So we're going to be looking for a description that says it moved our function to the right 2 times and it moved it up 5 times. And if you want to verify, right, you can actually count the little marks, right? We went over 1, 2, and then we went up 1, 2, 3, 4, and 5 because that now lines up with 5. So let's take a look over here. This says the graph of f is translated 2 units. They got the 2 in there already for us. And we're going to say to the right. And then it says in 5 units up. And that's it. That's exactly what happened. So now pause this video and try number 28 before proceeding.